Hi, welcome to the Section 1 to 5 notes, day 2 of that, and this is on angle measures and relationships with a focus on algebra. So first of all, it says angles 1 and 3 are what kind of angles? If you look at those angles, again, we are referring to this angle and this angle. And if you think about what kind of angles they are, again, I see a big X there, and it's two intersecting lines, and so those angles are vertical angles. Okay, and then it says angles 1 and 2 form a what? So now we're talking about this angle and this angle, and I can see it's two angles, and they're forming a straight line, so therefore they form a linear pair. And again, the way I mentioned that to you in class, I think of the fact that the word pair means two, and linear has the words line in it. So it's two angles that are forming a line. The next thing it says is, what is the measure of angle 2? Well, I can see up here that it says angle 1 is 60. So I'm going to put that in angle 1 spot. And if we just said that angle 1 and angle 2 form a straight line or a linear pair, then we know that angle 2 has to be 180 minus 60, which is equal to 120 degrees. Okay. And it says, then what is the measure of angle 3? So if we can see angle 2 and angle 3 form a linear pair, so therefore they add up to 180, then again, I can go 180 minus 120 to get angle 3, and now I'm back to the 60. And now it's saying, what do you notice about the vertical angles? So therefore, these vertical angles are congruent to each other. And vertical angles are always going to be congruent to each other. So they are congruent. Remember, a congruent's that equal sign with the squiggly on top. All right, so let's move on to example 1. And we're still using this picture up above. We're just not using the number values that they gave us up above. So it says use the figure above, but do not use the angle measurements for above. So I'm going to go ahead and get rid of those. I'll keep the fact that those vertical angles are congruent. That might come in handy. So here it says measure of angle 1 is 2x plus 25. So I like to write that in the angle. And it says angle 3 is x plus 45. And we already said they're congruent to each other, so therefore I can set them equal to each other. So 2x plus 25 is equal to x plus 45. And if I go ahead and subtract x from both sides, then I get x plus 25 is equal to 45. If I go and subtract 25 from both sides, then I end up with x is equal to 20. Again, I always want to look to see what they're actually asking for. This time they're just asking for what x is, so I'm done there. Okay, if we keep on going here, now we're talking about perpendicular lines. So the symbol for perpendicular is that upside down capital T. So they often use that instead of writing out the whole word perpendicular. And it says perpendicular lines are lines that form right angles. Okay, and it says when lines are perpendicular, the following statements are also true. It says perpendicular lines intersect to form, and actually 4 right angles. Okay, and it says perpendicular lines intersect to form 4 pairs of adjacent angles. Remember, adjacent means the word next to. And it says segments and rays can be perpendicular to lines or to other segments or rays. And it says the right angle symbol in the figure indicates that the lines are perpendicular. So again, if we know that two lines are perpendicular to each other, then we therefore know that all of these angles are right angles, and therefore they are all 90 degrees. The second statement here is saying perpendicular lines intersect to form 4 pairs of adjacent angles. So that's also true that, there's 4 pairs of angles that are right beside each other. All right, on example 2, it says find x and y so that line BE and line AD are perpendicular. So if we assume they are perpendicular, then again, we would know this is a right angle, this is a right angle, this is a right angle, and this is a right angle. Okay, so if we try and set up true equations with that information, if I start with the x's, I know that these two angles making up this angle and this angle have to add up to 90. So I can say 6x plus 3x is equal to 90. So I've got 9x is equal to 90. So therefore, x is equal to 10. It's also asking us to find y, and we can see this 12y minus 10 is also equal to 90. If I go and add 10 to both sides, I get 12y is equal to 100. And if I go ahead and divide by 12 on both sides, I could write 100 over 12. If I want to go and reduce that down, I've got 50 over 6. And if I want to go ahead and write that as a mixed number, I would have 8 and 1/3. Or if I want to write a decimal, I'd have 8.3 or 8.3 repeating. So sometimes you're not going to get a whole number as an answer. Okay. All right, if we go ahead and move on along to the next page, it says example 3, and this one would be a good one for you to try on your own. So I would recommend pausing the video and trying this one. Again, paying attention to the wording, drawing a picture, and setting up your true equation, solving for A, and then plugging back in for what it's asking for. So that'd be a good thing to try. And then come back on and see how you did. I'm going to go ahead and work it out now. It says rays BA and BC are perpendicular. And it says point D lies in the interior of triangle ABC. So first of all, before I go any further, I need to draw a picture that fits that information. So we're talking about two rays. One's BA, one's BC. So both rays start at B. So when I draw that, and it's telling me they're perpendicular, which means I know they're forming a right angle with each other. And I know the common point between them is B, so that's going to be at my vertex. And so I'm going to go ahead and put A over here and C over here. Okay, and now it is saying that point D lies in the interior of triangle ABC. So remember, interior means inside. So I'm going to put point D right here. And I'm going to go ahead and draw this line, okay? Because now we're talking about some angles that have the D in there. So now it is saying that angle ABD is 2 plus 3A. So I want to fill that in. And it is saying that DBC is 2A plus 8. And they want me to find some things, but again, I'm not going to pay much attention to what they are asking me to find first. First, I want to set up a true equation, and I want to be able to solve for A. So since it told me that these rays are perpendicular, I need to have a right angle there. And once I see that right angle, that's my clue that these two angles have to add up to 90. So I'm going to say 2 plus 3A plus 2A plus 8 is equal to 90. So if I combine my A's together, I get 5A. And combine my 2 and my 8, I get 10. And that's equal to 90. If I go and subtract 10 from both sides, I end up with 5A is equal to 80. And then if I divide by 5 on both sides, I end up with A is equal to 16. Okay, and so now I can plug back in for what it's actually asking for. It wants the measure of angle ABD. And ABD is 2 plus 3A. So I'm going to say 2 plus 3 and then substitute my 16 in. And if I go ahead and solve for that, I end up with 2 plus 48, which gives me 50 for ABD. And then I also need to find the measure of angle DBC. And if I go ahead and plug in for that, for the 2A plus 8, I've got 2 times 16 plus 8. And that's equal to 32 plus 8, which is equal to 40. And again, if I want to do a quick check of my answer, then I can always, if you want to plug these back into your picture, here's my 50, here is my 40, and I know that, again, if I'm checking this, I should add those up, 50 plus 40, and I can see I get 90, and that's what I was supposed to get. So I know that this checks out, right? Okay, so now we are going to move on to translating from English to algebra. So first of all, if we just go through this wording and kind of write symbols that go along with that wording, that will help us do the word problems that are down below. So when it says the measure of an angle, that's kind of an unknown. We're going to just call that X. If we say the word more than, we're referring to adding. If it says supplementary, we're talking about two angles adding up to 180. And if it says the word supplement, that means that if it's referring to one angle and then it says something about the supplement, then it means those two angles add up to 180. But whatever that initial X is, the supplement is 180 minus that. So that's what we're going to refer to here. The word is where we're going to substitute in for equal sign. Less than, we're going to subtract. Complementary means two angles that add up to 90. And if it says the word complement, that means that whatever the X is, if another angle is the complement of that, it means it is 90 minus X. Okay, so we can use those to help us down below. So if we start reading these, we want to set up a true equation based on the wording, and we can kind of use our little guide up above to help us out with that. So when it says the measure of an angle, okay, all of that is referring to our X, like we have up above. Okay, the next thing it says is the word is, and that we're going to write our equal sign. And then it says the 100 here, so I'm going to write 100. And it says 100 more than, okay, so our more than, we're putting our plus. And then it says 3 times its supplement. So 3 times its supplement. So I'm going to have my 3. And when we're talking about, it's not turning out good. When we're talking about 3 times its supplement, we said for supplement, we're going to do 180 minus X. And so we want to put parentheses around that to show that we're multiplying the 3 times the 180 minus X. And then that's our equation. And now we need to solve to figure out what that angle is. So if we go ahead and distribute that 3, I like to show that I'm distributing the 3 with the arrows. So if I go ahead and distribute that 3, then I can write 540 minus 3x. Make sure you're multiplying that 3 by both terms. And now if I combine my like terms together, I end up with 640 minus 3x. I can go and add 3x to both sides. So I end up with 4x is equal to 640. And then if I go and divide by 4 on each side, I get x is equal to 160. And in this particular case, the directions say find the angle, and we had already said that the measure of the angle was x, and so that is our answer. Okay, we don't need to go further than I'm asking us to. Two more examples that go along with this. If we look at example 2, it says the measure of an angle's complement is 42 less than the measure of the angle. Find the angle. So same type thing here. It's just referring to the measure of an angle's complement. That we said is the same thing as 90 minus x. We've got our is, so that's our equals. And then it says 42 less than the measure of the angle. So you've got to be careful with that. Anytime we're talking about subtraction, the order matters. When we're talking about adding, the order doesn't matter. But in this time, we're saying 42 less than the measure of the angle. The measure of the angle is our x. And then we need to go minus 42. We need to take 42 away from that. And now we're solving from there. If we go ahead and add x to both sides, then we will end up with 90 is equal to 2x minus 42. If we go and add 42 to both sides, we end up with 132 is equal to 2x. And then if we go and divide by 2 on each side, we get x is equal to 66 degrees. Again, the question is saying find the angle, and the angle is what we plugged in for x. So we're good there. And then the last one says that angle 1 and angle 2 are supplementary. And it also says angle 1 is 18 more than twice the measure of angle 2. Each of those sentences represents an equation. So again, if I think of what the word supplementary means, I know that it means it equals 180. And I could use angle 1 and angle 2 in the problem, but sometimes that confuses people. So I'm just going to call angle 1 x and angle 2 y, and which means I'm also going to put x and y in for the other equation. So if I write an equation that represents the first sentence, if angle 1 and angle 2 are supplementary, I can say x plus y is equal to 180. That is a true equation that fits that first sentence. The second sentence says angle 1, which I'm going to call x, is, which is equals, 18 more, so 18 plus twice the measure of angle 2. So 2 times whatever angle 2 is, which I'm going to say is y. If you look at these equations, we have two equations now. They both have x and y in them. So if you think back to algebra, what method you used, we haven't talked about it yet in geometry, but if we have two linear equations that both have an x and y in them, we can use substitution or elimination to solve the system of equations. In this particular case, since x is already by itself, I think substitution would be easier, but you can technically do either. So substitution means that if I want one of the variables by itself, which there's already an x by itself right here. So if x is equal to all this stuff, I can put all of that stuff in for x's place over here. And when I do that, then I've got 18 plus 2y, and then I have plus y equals 180. So I've got 18 plus 3y is equal to 180. If I go and subtract 18 from both sides, I get 3y is equal to 162. And if I go and divide by 3 on both sides, I end up with y is equal to 54 degrees. Again, find, if you pay attention to the directions, it says find the measure of both angles. We found one of them. And so I need to plug in to solve for the other one. So when I do that, if I know that y is 54, I can come over here and figure out what x is. And I can say 18 plus 2 times 54, which gives me 18 plus 108, which gives me 126 degrees. So here are my two angles. I can say that the measure of angle 1, I said was x, and I found out x is 126. and I called angle Y. Angle 2 is Y. So I found out that Y is 54. And so that's my answers. Again, if I want to do a quick check, I can add those two angles up, 126 plus 54, and show that that equals 180. And since it does, then I know those are right. All right, one more section to go, and that's section 1-7 that we'll do next.